Hello everyone, welcome to lecture number 15, sorting a linked list. Sorting a single linked list, basically we are discussing about single linked list, right? So we are going to follow merge sort. Yeah, I know I haven't made any videos on sorting, but yeah, merge sort is easy to understand. So I'll explain a little bit of merge sort here on a high level. Then later when I've made a sorting video, you'll understand more about merge sort in arrays, like we basically do in arrays, right? So now we are doing merge sort on linked list. Yeah, it may, like, for me it is like I approach the problem very easily. So when I thought about the approach, like how my approach will be, I got the code, right? Yeah, it's that simple. If I got it, you'll get it. Okay, so you don't need to know about merge sort. So let me explain what merge sort actually is. So let's say this is my array. So basically understand on array level, then we'll shift to linked list. -1, 2, 3, 4 and 0. Okay, so now every time what you will do is you'll find the middle and you will break it. Okay, so in this case, what's my middle? This one, right? So now I'll split it into two arrays. One array goes to -1, 2 and the other one goes to 3, 4 and 0. Okay, so now as there is 2, you can still split them. So you'll also split them, -1 and 2, and here 4 is the middle, so I'll split like this, 3, 4 comma 0. And now there is no scope of splitting here because only one element left, and we'll split these two. We'll split 4 and 0 2. Okay, so now first of all we'll sort these two. Okay, -1 is less than 2, right? So that means they are in the correct position of here. At this level they are at the correct position. So simply what we can do is we can merge them. Now we have splitted everything, right? Now we need to merge them. That's what merge sort says. Split first, merge later. Okay, so now when we split, when we merge it, -1 will stay as same, -1 and 2. So yeah, this is, so let me use a different thing, which is -1 and 2, which is left on the left side. Okay, so let's discuss about this one. This is greater, right? So now we'll swap these two. So when we swap these two, we'll get 0, 4, right? And here it is still 3. Okay, so now what we'll do, so let's say now we need to compare these two, right? So now after, while we are merging, we need to compare, and we'll sort this list 0, 3, 4. It's just comparison. Okay, and now we have got this array, and now the next thing is we need to merge these two. Okay, so now -1, next is 0, next is 2, next is 3, next is 4. I think you had got this problem. I know you may be in confusion that how you are merging these two based on, right? So first, always I'll change my color. It's fine, this color here. Now you'll keep a pointer here, like, I mean, this is the first thing. Let's say this is a left list, and you keep a thing on this here, right? Okay, so now let's say left value is less than right. That means you need to consider left value into your array. So that means you'll insert -1 and you'll move a pointer here. That means L is standing here. Okay, so now you'll compare this with R, whether which is less, R is less, right? So you'll keep R value here and you'll move the R pointer to the right. And now 3 and now 2, which is small, 2, right? So we'll keep 2 and we'll move end of the list. So this is cancelled, so only these are left. Simply we can do 3, 4, we can simply insert. In this way we are sorting a array. So if you see, this is almost similar to linked list, right? So now let's see what we'll do with the linked list. Let me draw a line. Yeah, I'm bad at separating this. So now, so let's say now these are lists. So we'll convert the same into lists. -1, this will point to 2, and this will point to 3, and this will point to 4, and this will point to 0, right? Okay, so now we'll find the middle, this middle, and now from here we'll make two lists. So this already a head pointer is there here, so this is a head pointer, and now you found the middle, this is middle. And now what you need to do is you need to consider two parts of this. Okay, so first part will be this and second part will be this, right? So now this will be my left part and this will be my right part. okay? But before, if you want to split it more, you need to break this link, right? So that left and right will become independent. So to make that, we need to do mid dot next will become nil, right? And now your left and your left and your right, now you'll carry on the split. Let's say you have made it -1 and you have made it 2, okay? So you'll stop splitting here. Why? Because your head has only one node. That means there is no further splitting needed. That means you can keep a check head dot next equals to nil, or head is equals to nil. If both are proper, then if either nil or head dot next is nil, then you can stop your splitting and you can start merging, right? That's what you'll learn about merge sort. First split, then merge, okay? So now we have splitted this value, and in the same way you'll split this, okay? So in the same way, now you have brought to a condition where sorry, I have made a wrong decision, I guess. Here there will be 2 values. This is connected to 3, and now from here you'll split 2. This is 2 and this is 3, right? So now from here, so now you need to merge these 2 lists. So here everything is breaked, right? So L1 is here, and left is here and right is here. So let's keep a dummy pointer at individual level, okay? So let's keep a dummy pointer which points to some a node with nothing value. Let's say -3 or something value, which is nil, okay? And now we'll keep a left pointer and we'll keep a right pointer. So now which of the value is less? Left is less, right? So we'll attach left here, okay? And we'll move the left pointer now, which will point to nil, and this will cancel out. And now we reach to this position 3 to the right. So these left is completed, right? You are only left with right, so you need to traverse all the right array, and you can simply connect this 3, and you'll simply return dummy dot next, okay? So this is your merge thing, right? This is how you merge, like placing a left pointer to the left list and the right pointer to the right list, and from here you'll loop, okay? And while splitting, it's just simple, right? You need to keep a head which is always pointing to the start of left list, and right list you need to simply make mid dot next will be a right split, and you need to break this node, so you need to make mid dot next is nil, right? So in this way you can solve linked list. So let's see height of the tree. So what is the height of the tree? Log n, right? So right, that's what, right? So that's what your splitting takes. Now each split, now you need to iterate n times, right? You are iterating left array and right array, so it's almost equals to n log n. So which is the time complexity of sorting a linked list, right? Okay, so what will be my space complexity, which is the height of tree, right? Which is log n. Why? Because too many like only the stack trace is being formed, and this consumes some memory. Like stack tree consumes some memory, so you can simply say that this is your space complexity, okay? So I hope you got this, how you can sort a linked list. So if you have any doubts, please feel free to comment. I'll be discussing that, because yeah, at the first time when you see this, you may have like how will you approach a problem. Like I have a simple understanding of merge sort, how merge sort works. So from there I have built this solution, like just splitting, and what if I get right, what if I get left, and after getting left, what you need to split, right? You just need to split until nothing is left. So that's what the concept, just split and merge. While merging, you need to check whether which value is less, and from that we need to add to a dummy array, and from there we'll return the dummy array. Yeah, like while seeing this everything logic, you may face difficulty, right? Yeah, this is marked as hard problem in lead code. Yeah, so you will face some difficulties in sorting this. Like if you got this problem, how to solve a linked list sorting, then you have got almost every problem in linked list, right? So you can say that this is the first hard problem you are going to solve in linked list. Until now we have solved only normal problems, right? Understanding the algos and everything. But from here we'll discuss some hard problems and linked list. So you can say that this is one of that hard problem. If you understand it, if you understand this problem, no, then in upcoming problems when we are going to solve individually, then you are going to get almost you will get an intuition how to solve that problem. Okay, yeah, if you have any queries, please feel free to comment it. For sure I'll be replying there. Okay, so let's jump into our coding session. So let's see how we can write code for it in Go. So here if you see, we have a sort list function. Okay, so now like forget about the left part, so just consider the split part. You'll send your head, so which means that you need to split, right? If see the split list, so every recursive function has a base condition, right? You need to somehow stop the recursion. So to stop the recursion, either the head should be null or it should be a single node, right? So you can simply return your head, which means in this case it's null, in this case this is head. Okay, so now how to find the middle? We have already discussed in our previous lectures that how to find the middle of the list. I have wrote the function above, I'll show it, but you can simply call this middle list function, which will give you the mid node. From here left list will be your head and right list will be your mid dot next, right? And as we discussed, we need to some completely break the left list and right list, and mid dot next will be nil. Okay, so we'll let's say now here if you see split list dot left list and split list dot right list, that means here inside it is still making some recursive calls, and in the split list of right list where it's still making the recursive calls. Okay, after the entire recursion is completed, that means after all the left part is sorted, all the right part is sorted to every individual values, and this merge list function works from there. Okay, so let's see how merge list function works. So we have a left list and we have a right list, and we'll, as we said, we'll keep a dummy node and dummy pointer which points to dummy dot head. Left list not equals to nil and right list not equals to nil. If left list dot value is greater than right list value, that means you need to include the right node from the right list, right? Because right list has the lesser value, and vice versa on else condition, and you need to simply move the dummy pointer. And you need to also, let's say the right node is completed. In case of odd, you'll have your left list or right list completed first, right? So to avoid that, we need to iterate all the empty thing, and here also the same, and we can simply return the dummy dot head dot next, which we discussed. Like the first node is just a temporary row node. So this is your middle list function. Okay, after entire list is sorted, that means it's basically returns the head, right? SLL dot head. So in that way, if you see, we can simply assign SLL dot head to split list. Yeah, I know we cannot assign the tail pointer, so to do that we need to iterate. So you can have that logic if you want, because after sorting the tail will go somewhere in the node. We can't guarantee that it stays at the last. So you can write a logic. If you have any doubt, make sure to comment. I hope you are liking my videos. Make sure to like and subscribe. Yeah, that's it for today. So let's meet in our next lecture.